What can we talk about here? Feeling okay about this? It was just 11 through 16 on that front page and the rest down below. What can I help you with? 14. You got it. Number 14. All right. So that one right there, right? This is definitely one we want to use on Desmos. And it's definitely one that's going to be like a simple answer like 4 or 5 or -2, or it's going to be something. It's going to be like a whole number for the x that we're solving for, but it's going to cross at like a high number. All right, so let's plug this in. So 9y equals 9 raised to the parentheses x plus 4. And then y equals 27 to the x minus 3. All right. So, I take that back. I don't think these are going to intersect at a really high level. I think they're crossing somewhere down here. But I don't know. Let's see. It's not getting a grade dot. I don't think it's going to be some wacky number like that. All right. So, and this one they won't intercept at some high value. I mean, we can double check. We can kind of scroll out and see if we get something in the decimal range. All right. If this doesn't work, then another way to try it is to graph both of these as one equation. So you have to make one of them a negative. It doesn't really matter which one's negative. Oops, forgot the parentheses, sorry. And we don't need XX. So if I made this one positive, then I'm going to subtract the 9x to the plus 4. And if we do this way, hopefully this will cross the x-axis. X plus 4. Now let's turn both those off. And we're going to take this back to home. Okay, so notice it flipped upside down. I bet you all agree with that. And I'm trying to find a value back here. That gives me a gray dot, and I'm not seeing a gray dot. All right, so now we are at kind of a weird spot to work the problem. So I think the best thing to do at this point is this. So let's go back to some things that we probably would be able to kind of figure out. Are you okay that we said that if I just had 9 and I just had 27, is 9 the same thing as 3 to the second? Do you agree with that? Are you okay that 27 is the same thing as 3 to the third? 3 times 3 times 3 is 27. So I'm going to take these and I'm going to replace it with my 9s. And so then I'm going to get 3 raised to the second x plus 4 equals 3 raised to the third x minus 3. Okay, do you see what I did? Okay, in the world of algebra, the 3's at the bottom, these are our bases. Those are the same now. So then that means that I can go, okay, well, if I do this, and I set it equal to this, and I do a little bit of math, and I do a little bit of math here by distributing, 9, 9, 9. Okay, subtract 2x from both sides. Add 9 to both sides. So this is coming out to x is equal to 17. Oh, wait a minute. This kind of makes sense to me. Okay, so if x is equal to 17, watch what would happen. And again, this becomes the goofy thing with these. Kill that. Okay, so if we go out to 27 in the x direction, now I'm going to just make this right. So this is going to this is a huge number. Hey, how are you? Good, are you? Oh, well. And I don't know if it's necessarily worth doing it. This might be one that, if you were in a business world situation, you might be able to. Yeah, you're talking a huge number. Basically, that means if you plug 27 in, you'd get 9 raised to the 31st power, which is 9 times itself. So I don't know if we can expand this out far enough to give us a point where they're going to intersect each other. I can close that and just keep zooming out. Yeah, I mean, we are extraordinarily huge numbers. I mean, 6 times 10 to the 19th power is 6 with 19 zeros behind it. I don't even know what number that would be in real life. So that might be one that you would want to make sure you knew that one way to. If you hit 9 raised to the 31st power, it's 3.8125 times 10 to the 29th power. That's enormous. I mean, you guys get the perspective of how big some numbers are? Maybe we can talk about that in a little bit. All right. What else did you see on the homework that can help you out? Yeah. 2, 4. Cool. Okay. We are going to use the g at x equation, which is this. Okay. So what we're going to do with this is we are going to substitute x plus h in for that. So the first thing I'm going to do is I'm going to do 2x plus h plus 5. And then I'm going to subtract this. So I have to make sure I have a negative go here and here. And it's all divided by h. Does that arithmetic seem to make sense? Cool. Clean it up a little bit. Distribute here. That's going to give me 2x plus 2h plus 5 minus 2x minus 5 divided by h. 2x and minus 2x cancel. Positive 5 and negative 5 cancel. So then I wind up with 2h over h. And then you can reduce there. And the answer just comes out to be 2. That's the basic definition of a derivative, which we will get into a little bit in the future. Any other questions I can help you with? Yeah. I love it. I love it. Okay, yeah. Let's take a look at, let me go to, let's go to this. So if I have, let's say we want to know the domain, and I'm just going to make one up. This is not on your homework. Let's say we knew, if we wanted the domain of each of these situations. If I had 3x squared, let's not go 3x squared. Let's go x squared. No, let's not even go that. Let's go like x plus 2 and x minus 3. And let's say it's less than 0. This less than is all parentheses. And if I had the same exact problem and I gave it to you like this, and I had this is going to have a square bracket someplace, okay? And what that basically means is this. If I had graphed this as a parabola, this is crossing at -2 and at +3. And so this would have been a dotted line. And so this, what they want here is they want less than 0. So they want this region down here. So I'm going to go from here to here, but I have the less than. So I'm going to go from -2 to +3, and it's going to be parentheses. Okay? It's the same graph, but the domain on this one, because I had this, it would be square brackets because I have the equal sign. Okay, you have this underneath there. Okay, that's basically where you're going to come across that. If this was this equation, so I'm just going to flip the sign over. That's going to be the same parabola, but that means that I want, because it's bigger than 0, I want above. So this is going to go from -infinity to -2, and then it's going to go from 3 to infinity. And if I had the same equation with the equal sign, but I flip the sign over, this is going to go from -infinity, still soft bracket because I can't get there, but then it's going to go to -2, and this is going to be a hard bracket because of that, and then it's going to go a hard bracket from 3 to infinity. That's basically what is, yeah, because I can't get there. I get close, I approach it, but I can't ever get there. Like, think of your largest number, which we all have a biggest number we could probably fathom. Okay? All right. I wanted to try something. I can do it on decimals. All right. So, any other questions off the homework? You feel okay with it? Everyone's happy. I'll be marking it off here in a moment. I want to talk about large numbers. And I need somebody to find out what the population of the United States is right now. So please, someone look that up for me. Oops. $340 million? Cool. Keep that idea going. Oops. All right. You guys recognize that? You ever taken chemistry? Avogadro's number, 6.02 times 10 to the 23rd, which basically in simplest terms means if I had a pure substance, one of the elements off the periodic table, let's say we took gold. If I had 1 gram of gold, I would have 6.02 times 10 to the 23rd atoms of gold in that 1 gram. Okay, so that's pretty huge. Now, you told me the population of the United States is what? 340 million. Okay, so that's the population in the United States. So why I'm doing this is basically when we were looking at that one graph, we were at 6 times 10 to the 19th, which is extraordinarily huge. Think about how huge stuff is. So friends, think about this. If I were to take 6.02 times 10 to the 23rd And I'm actually going to put this in parentheses. So let's say we had this many dollars, 6.02 times 10 to the 23rd dollars. You still with me? And if I divided that by the population of the United States, which you just told me is 340 million, that means that everybody on the planet or in the United States gets 1.7 times 10 to the 15 dollars. Now, if we went even further and said, okay, if I get that many dollars, could I, let's do a little dimensional analysis. If I said, I want to multiply that by 365 days, so 1 over 365, this means that each day that we could spend 4.85 times 10 to the 12th dollars every day. And if you went a little bit further and said, well, how much is that per hour? That means that 1 divided by 24, because there's 24 hours in a day. This means that we could spend 2.02 times 10 to the 11th dollars every hour, every day for 1 year. And if I went even further, if I wanted to say, well, how much is that every minute? I can say, well, there is 60 minutes in an hour. So I can spend 3.3 or roughly 3.7 times 10 to the 9 dollars every minute of every day for 1 year. If I went even further and said, I want to figure out how many seconds, how much I could spend each second. So that means that you can spend $56,144,984 every second for every minute of every day for 1 year. I don't know about you guys, but challenge accepted. Give me that money. I'm going to see if I can do it. Deal? All right. So we do indeed have a quiz tomorrow. Okay. It does talk about, two of the questions are based on the taxes that we had done on Friday. So if you missed Friday, good thing we're working together. Okay. Does everybody understand that tax structure that we had done the other day? Does anyone want me to review that a little bit? Want to see it reviewed? Okay. All right. So I'm going to pull myself up. Let's see. Google 2025 tax brackets. So this might be the one I have. Okay, so shift that S. No, control. And there it is. I want to take a picture of that. Let's see if I can insert that. Pictures, screenshots. That might be it right there. No, that's not it. That's it right there. All right, and I am going to copy this. Let's see, copy. Go back to here, paste. Come on, baby. There we go. All right, and I can probably bring this down to a nicer size. All right. So you have two basic columns that you're going to use. You're going to use this column once each time. Once is for a single file, and once if you are married. Okay. And I basically phrased the question as how much can I do? So let's just do it for a single couple. It's done the same way for married. So let's say you make $51,250 in a year. Okay, and let's say that's your taxable income. So basically, you're going to say, okay, I'm going to take 11,925 and I'm going to multiply that by 0.10, which comes out to 1192.50. Okay, and then being that we're up here, somebody subtract these for me on your calculator. 48,475 minus 11,925. Subtract those, please. Anybody subtract? 36,550. Will you multiply that times 0.12, please? 4,386. Okay. And then, so then we're falling into here with our 51,000. So will you go 51,250 and subtract 48,475 from that for me, please? So I'm looking for this subtraction. $3,000? Okay, will you multiply 3275 times 0.22, please? 720.5. Okay, and the last step to that is, will you add those up for me, please? So 1192.50, 4386.00, 720.50. Anybody? See a couple people who are vigorously doing stuff on their phone. We'll make a rule: if you're on your phone, starting in the next 30 seconds, you get to do the test on your own. Do we have an answer yet? Okay, this is what you owe in tax to the federal government. Okay, so of your $51,250, you're losing almost $6,300 of that to the federal government. Okay, let's see who pays attention. Give a nudge to whomever's not looking. You done yet? We good? All right. So I'm going to mark off today's assignment. And let's see. Is there any reason why we should assign you anything. No, we'll be hitting this stuff tomorrow, or excuse me, Thursday. And then Friday, we are going to show you how to lower your taxable income, meaning the amount of money that you give the federal government, which is good. Okay? So, and everything that I will show you is totally 100% legal to do. When people say it's not fair, people are sheltering their money. I will tell you that people that are in a career position, they are indeed lowering their taxable income a number of ways, including if you choose not to even do it, there's something that's called the standard deduction. The standard deduction is an automatic way to say, I'm going to lower my taxable income because the federal government put it in place. Okay. And there's a couple of tricks to the trade of that, but I will talk about that on Friday, and that should be helpful for you. But any other questions off the homework? Or you feel safe? You feel confident? You feel good? Happy? Test tomorrow? Yes? I heard we have a fire drill today in the West.